The sound begins not with a roar, but with a sharp, violent intake of breath. Imagine a heavy iron door, 4 feet high and shaped like a horseshoe, sealing shut with a hiss of rubber and grease. Then, the low, rhythmic thrum of a 24-foot centrifugal fan, a massive iron beast hidden in a brick chamber, begins to spin. You are standing 30 feet beneath the cobblestones of Holborn in 1863. The air is thick with the scent of hot tallow, coal smoke, and something else, an ozone-sharp tang of manipulated atmosphere. Suddenly, a whistle shrieks, and with a jolt that vibrates through the very bedrock of London, a 2-ton iron capsule vanishes into the darkness of a cast-iron tube, sucked into the void at 30 miles per hour. This was the birth of the London Pneumatic Despatch, a Victorian dream of a city connected by a lightning-fast subterranean nervous system, a technological marvel that promised to render the horse and cart obsolete. Today, if you walk past the bustling entrance of Euston Station or the quiet corners of the Gresham Street Post Office, you are walking over a ghost. Down in the darkness, beneath the fiber optic cables and the modern sewer mains, the tubes are still there. They are choked with a century of London silt, their iron ribs rusted to the color of dried blood, forgotten by the millions who commute above them. The grand stations that once housed the massive steam engines have been leveled or repurposed into nondescript basements. There are no blue plaques for Thomas Webster Rammell, the man who dared to suggest that the fastest way to move the world was to suck it through a pipe. The paradox is staggering. In an age where we obsess over the instant delivery of data, we have completely erased the memory of the time we tried to achieve the same with physical matter, using nothing but the weight of the atmosphere itself. The Architect of the Invisible. The story begins in the feverish mind of Thomas Webster Rammell, a man whose name has been scrubbed from the pantheon of great British engineers, overshadowed by the titanic silhouettes of Brunel and Stephenson. While they were building bridges to span the world, Rammell was looking at the city as a biological entity that was slowly suffocating. By the late 1850s, London was a choked mess. The streets were an impenetrable sludge of horse manure, mud, and over 20,000 carts vying for space. A letter sent from the city to the West End could take hours, sometimes a whole day, to travel just 3 miles. Rammell, an engineer who had cut his teeth on the grueling work of the London drainage systems, saw the solution in the vacuum. In 1859, he founded the Pneumatic Despatch Company. His vision was not merely a mail service, it was a total reimagining of urban logistics. He secured a massive capital of £150,000, a staggering sum today, roughly equivalent to £20 million, and gathered a board of directors that included the most influential industrial capitalists of the era, including W.H. Smith, the newsagent magnate who saw the potential for his papers to reach the suburbs while the ink was still wet. Rammell didn't just want to build a tunnel. He wanted to create a atmospheric railway for things. The Battersea Proving Grounds. To prove his skeptics wrong, Rammell didn't start in the crowded streets of the city. In the summer of 1861, he constructed a test track in the muddy wastes of Battersea, near the site of the current power station. It was 450 yards of cast-iron tubing, curving and diving to simulate the chaotic topography of London's underground. The trains were simple iron cradles on 4 wheels, designed to fit the horseshoe-shaped tunnel with only an inch of clearance. The seal was provided by a thick fringe of bristles and leather, essentially a giant brush that scraped against the iron walls, creating a near-airtight chamber. On the day of the first demonstration, the atmosphere was one of high-stakes theater. Skeptical journalists from the Times and the Illustrated London News stood by as a steam engine, a classic Boulton and Watt design, began to turn the great fan. When the signal was given, the carriage was sucked through the 450-yard pipe in less than 30 seconds. To the Victorian observer, this was nothing short of magic. There was no smoke, no fire, no visible means of propulsion. It was the power of the void. Rammell, in a moment of characteristic bravado, even invited a few brave souls to lie down in the mailbags and be fired through the tube. They emerged at the other end, disheveled and covered in soot, but exhilarated. They had traveled through the earth on a cushion of air. Breaking the streets. The success at Battersea gave Rammell the leverage he needed to begin the real work. In 1862, the first permanent line began construction between the Northwestern District Post Office and Euston Station. This wasn't the clean, automated boring of modern crossrail. This was manual, brutal labor. Navvies, the forgotten backbone of the British Empire, toiled in 12-hour shifts, digging up the very heart of London with picks and shovels. The aesthetic of the project was pure industrial Gothic. The tunnels were lined with massive cast-iron plates, bolted together by men working in the dim, flickering light of tallow candles. The air in the workings was foul, a mix of damp earth and the leaking gas from the mains they constantly accidentally ruptured. The project was a logistical nightmare. Every foot of progress required negotiating with the labyrinthine authorities of the Victorian metropolis, the sewer commissioners, the Gaslight and Coke Company, and the suspicious residents of the wealthy Bloomsbury squares who feared their houses would sink into the vacuum. Yet, Rammell pushed on. He wasn't just building a pipe. He was weaving a new thread into the fabric of the greatest city on earth, oblivious to the fact that the very system he was creating was destined to become a tomb. By 1863, the experimental success at Euston had emboldened Rammell to attempt the impossible, a grand artery stretching from the heights of Euston Station down to the very heart of the city at Gresham Street, with a massive central engine cathedral at Holborn. This was no longer a toy, it was a high-stakes engineering gamble. The scale of the second-generation tube was formidable. While the first Euston line used a modest 30-inch pipe, the new main line was a literal iron throat, 4 feet 6 inches high and 5 feet wide. Each section of the tube was cast in 8-foot lengths of solid iron, weighing nearly a ton each. To lay these, Rammell's army of navvies had to descend into the Under-London, a chaotic realm where the newly built sewers of Joseph Bazalgette crossed paths with ancient forgotten burial pits and the toxic seepage of 1,000 Victorian gas mains. The heart of the machine, the Holborn engine house. The technical nerve center of the entire system was the Holborn Station, located at 227 High Holborn. To stand in the engine room in 1865 was to witness the pinnacle of mid-Victorian mechanical ambition. At its heart sat 2 massive high-pressure steam engines, designed by the firm of James Watt and Company. These weren't mere engines. They were titans of brass and black-painted iron, generating a combined 800 horsepower. They drove the Rammell fan, a masterpiece of centrifugal engineering. Measuring 22 feet in diameter, this fan was a hollow, disc-like structure made of riveted iron plates. As it spun at 160 revolutions per minute, it didn't just move air. It manipulated the very weight of the atmosphere. The system operated on a simple but brutal physical principle, the plenum and the vacuum. To send a train toward Euston, the fan acted as a giant bellows, blowing a column of air into the tube at a pressure of about 10 ounces per square inch. To bring a train back, the valves were reversed, and the fan became a giant lung, sucking the air out and creating a partial vacuum that pulled the 3-ton iron capsules through the darkness. It was a closed-loop system of elegant violence. The rolling stock, iron capsules, and bristle seals. The trains themselves were marvels of utilitarian design. These were wrought iron carriages, 10 feet long, shaped like a horseshoe to mirror the tunnel's profile. They didn't have engines, pistons, or fuel. They were essentially passive projectiles. The most critical technical challenge was the seal. If air leaked around the sides of the carriage, the pressure would drop and the train would stall in the lightless void beneath Tottenham Court Road. Rammell's solution was ingenious, but archaic: the brush flange. The edges of each carriage were lined with a thick, stiff fringe of Russian hog bristles and strips of vulcanized India rubber. As the carriage moved, These bristles scraped against the cast iron walls of the tube, creating a near-perfect air seal while allowing enough flexibility to navigate the tight curves of the route. The sound of this, a massive, rhythmic scratching echoed through the iron pipe, was said to be audible in the cellars of the buildings directly above. Each carriage could carry 3 tons of mail or freight, moving at a steady 30 miles per hour, a speed that was frankly terrifying in an era when a heavy mail coach struggled to average 6 miles per hour through the congested London slush. The economics of the void. The cost of this mechanical dream was astronomical. The extension from Holborn to Gresham Street alone cost the Pneumatic Despatch Company £180,000, roughly £24 million in modern currency. Every yard of tunnel was a battle against the London clay, a treacherous, shifting soil that expanded when exposed to air. Rammell had to invent specific timbering techniques just to keep the trenches from collapsing before the iron segments could be bolted into place. The competition was fierce and skeptical. The traditional post office bureaucrats, led by the formidable Sir Rowland Hill, the man who invented the penny black, viewed Rammell as a dangerous visionary. They demanded a level of reliability that the early steam engines struggled to provide. The friction of the bristles against the iron walls generated immense heat, and the rubber seals frequently melted or tore, leading to stalls where a carriage would get stuck half a mile from the nearest station. To clear these blockages, engineers had to perform pressure surges, cranking the fan to its absolute limit, risking a boiler explosion just to blast the iron capsule free. It was a high-tension, high-cost war against physics, played out in the claustrophobic shadows of the world's first industrial metropolis. By the autumn of 1865, London was gripped by a peculiar form of pneumatic fever. The London Pneumatic Despatch had transcended its status as a mere engineering project to become a symbol of the Victorian space age. On the evening of November 7, 1865, the company held an opening gala that remains one of the most surreal moments in the history of British technology. In the cavernous, iron-ribbed station at Holborn, long tables were draped in white linen and illuminated by the hiss of gas lamps. A group of the era's most powerful men, industrialists, MPs, and peers of the realm, sat down to a formal dinner inside the very tube itself. They toasted the health of Queen Victoria while sitting 30 feet below the surface of the earth, in a tunnel that smelled of fresh iron and high-pressure steam. The peak of the spectacle. This was the golden hour. The system was now a 3-mile iron artery connecting the Northwestern District Office, Euston Station, Holborn, in the General Post Office at Gresham Street. It was the fastest thing on the planet. To the Victorian public, the speed was almost terrifying. There are documented accounts of people paying the company's workers for the illicit thrill of being fired through the tubes. One famous story from the archives of the Illustrated London News describes a lady of high social standing who insisted on being placed in a mail cradle. She was sucked from Euston to Holborn in minutes, emerging at the other end with her bonnet slightly askew, but her enthusiasm undimmed. The involvement of W.H. Smith, the man who transformed the British news trade, added a layer of commercial legitimacy that seemed unshakable. Smith saw the tubes as the ultimate weapon against his competitors. He imagined a world where his newspapers, printed in the early hours of the morning, could be vacuum-sealed and shot across the city to arrive on breakfast tables before the first horse-drawn cart had even been harnessed. For a brief window in 1866, it seemed as though the horse was finally a relic of a primitive past. But as the spectacle reached its peak, the hidden mechanics of failure began to grind. The first major blow was not technical, but bureaucratic. The General Post Office, GPO, led by the arch-traditionalist Frank Ives Scudamore, was playing a ruthless game of financial chicken. While the Pneumatic Dispatch Company had spent nearly £200,000 on the infrastructure, the GPO refused to sign a long-term contract at the rates Rammell needed to survive. They offered a paltry £3,000 per year for the service, a sum that wouldn't even cover the coal costs for the massive Holborn engines. Then there was the last-mile problem, a term we use today for Amazon deliveries, but which Rammell lived in 1867. The tubes were fast, but the loading and unloading were manual, agonizingly slow processes. Men had to heave 3-ton iron carriages onto wooden platforms, manually sort the bags, and then hand them off to more horse-drawn carts. The bottleneck wasn't in the vacuum, it was in the human interface. Technically, the system was becoming a victim of its own ambition. The Russian hog bristle seals were failing at an alarming rate. The friction against the cast iron walls was so intense that the tubes began to glaze with a mixture of carbonized rubber and pulverized bristle, which actually made them more slippery, but also created pockets of air leakage that the steam engines couldn't overcome. In the winter of 1874, a major blockage occurred beneath Skinner Street. A carriage carrying several thousand letters became wedged in a curve. For days, the engines at Holborn strained at maximum pressure, the safety valves screaming, but the carriage wouldn't budge. The only solution was to dig up the street, the very thing the tubes were designed to prevent. The irony of Rammell's struggle is that it mirrors our contemporary obsession with the Hyperloop in high-speed maglev systems. Just as Rammell promised to annihilate time and space with a vacuum, modern tech moguls promise the same. Yet, both face the same immutable wall: the sheer cost of maintaining a vacuum over miles of infrastructure, and the difficulty of integrating a futuristic node into a messy, ancient city. We look back at the 1860s and see a steampunk fantasy, but Rammell was grappling with the exact same variables of throughput versus infrastructure cost that dominate Silicon Valley boardrooms today. By 1874, the writing was on the iron walls. The company was hemorrhaging money. The GPO, seeing an opportunity to crush a competitor, formally withdrew their support, claiming the system saved only minutes compared to a fast cart. It was a lie, but it was a calculated one. On a cold morning in 1874, the fires in the Holborn engines were let out for the last time. The great 22-foot fan slowed to a halt. The hissing ceased. The vacuum was gone, replaced by a heavy, stagnant silence that would last for over a century. The subterranean nervous system of London was dead, and the city simply continued to crawl above it, oblivious to the fact that it had just buried its own future. The end did not come with a bang or a spectacular collapse. It came with the scratch of a bureaucrat's pen and the slow, agonizing evaporation of capital. In 1875, the London Pneumatic Despatch Company was officially wound up. The massive Bolton and Watt engines, which had cost a fortune to commission, were sold off as mere scrap metal for a fraction of their value. The great 22-foot centrifugal fan, once the beating heart of a futuristic London, was dismantled and melted down. But the most haunting part of the story is what happened to the tunnels themselves. Because they were buried so deep and constructed of such heavy cast iron, it was deemed too expensive to remove them or fill them in. So, they simply sealed the hatches. They bricked up the entrances at Euston, Holborn, and Gresham Street, effectively entombing 3 miles of cutting-edge Victorian technology beneath the feet of an advancing century. The ghost trains of the 1930s. For over 50 years, the tubes became a subterranean myth, a story told by aging engineers to their apprentices. But in the late 1920s and early 1930s, the ghosts returned. During excavations for new telephone cables and the expansion of the London Underground, workers repeatedly broke into mysterious iron voids. In 1930, at the site of the old Euston Station Terminal, a group of laborers smashed through a brick wall and found themselves staring into a horseshoe-shaped tunnel perfectly preserved by the lack of oxygen. There, sitting on rusted rails, were 2 of Rammell's original iron carriages. They were still filled with the dead mail of 1874, parcels and letters that had never reached their destination. The leather seals had turned to dust, and the Russian hog bristles were brittle to the touch, but the iron frames were as solid as the day they were cast. It was a time capsule of a failed future. One of these carriages was eventually rescued and now sits in the Museum of London, a strange, diminutive relic that looks more like a medieval torture device than a precursor to the internet. Tangible echoes. Where to find the void? If you know where to look, the scars of Rammell's dream are still visible on the surface of modern London. At 227 High Holborn, the site of the grand Engine Cathedral, the building has been replaced, but the basement levels still align with the depth of the original pneumatic vaults. Underneath the pavement of Gresham Street, utility workers still encounter the curved iron segments of the 54-inch pipe when repairing water mains. The most evocative remains are at the National Archives, where the original hand-drawn linen maps of the routes still exist, showing the vacuum way cutting ruthlessly through the basements of Victorian slums. In a strange twist of historical irony, the post office eventually realized Rammell was right. In 1927, they opened the Mail Rail, a driverless, narrow-gauge electric railway that followed almost the exact same logic as the pneumatic dispatch. It operated for 76 years, proving that the concept of a dedicated subterranean freight layer was not a fantasy, but a necessity. Rammell's only mistake was being born into the age of steam and bristles instead of the age of electricity and steel. The philosophy of the forgotten. The story of Thomas Webster Rammell and his pneumatic tubes is a mirror held up to our own era of disruptive innovation. It serves as a reminder that the success of a technology is rarely determined by its brilliance alone, but by its ability to navigate the messy, human world of politics, greed, and institutional inertia. Rammell gave London a nervous system, but the city's heart wasn't ready to beat that fast. We live in a world defined by the invisible delivery of things. Data moving through fiber optics, packages moving through automated hubs. We like to think we are the first to master the void. But every time you click buy and expect a result in hours, you are tapping into a desire that was first articulated by a man in a stovepipe hat, standing in a candlelit tunnel beneath Holborn, listening for the hiss of the atmosphere. Rammell was not a failure. He was a pioneer who arrived at the destination before the road had even been built. Now, as the Northern Line roars nearby and the fiber optic pulses flicker through the silt-choked iron of the old dispatch tubes, the silence in those dark horseshoe pipes is a testament to the cost of dreaming too big, too soon. The London Pneumatic Despatch remains a monument to the Victorian belief that even the air we breathe could be harnessed to conquer the chaos of the world.